Hello, I'm Anna Mackay and this video is on the inverse normal. Now to explain what that is, it's probably best to actually get straight on with an example. So our example here is that a manufacturer of metal rods uses a machine that, because of random errors, produces rods whose length is normally distributed with mean 1.3 metres and a standard deviation of 0.02 metres. And the first part is, it's decided to reject the bottom 7% of rods, implying that they're going to be too short, they don't meet the grade. Now, what would be the minimum length of rod allowed? Now, I always find it really handy to create a picture, draw a visual for yourself. So what we're implying here is we have a normal distribution, so just draw a little sketch. Sometimes it helps to put on the mean, if you've got that information, 1.3 metres. And try and think about where is this 7%. We're rejecting the bottom 7%. So that means that the area to the left here will be 7% or 0.07. But the thing is that we don't know is what is this value here. So if you were to use your NCD function in your Casio calculator, you would usually need a lower bound and upper bound, a mean and a standard deviation, and you'd get the answer of this. But this time around we don't know that. So we have to do an inverse operation, if you like, to try and find out what K is. So we'll set up on the next screen the probability statement for that. And then I'll show you the calculator screens there. So our probability statement would be that we want to find out, well, I'll put in what we know, that we're rejecting the bottom 7%. So our answer is going to be 0.07, and we put a K there. That's the value that we're trying to find. So when we come to answer this, we'll get a K value and find out what that answer is. And in the Casios, you go into menu 2, stat, distribution, normal, and push inverse normal this time. And you'll get a screen that looks like this. And here are your options. So the tail is left. So remember that little picture that we just drew? The options that you have are tail left, right, and sometimes centered, depending on which version you've got. So thinking about that, that tail is on the left. So that's why we choose tail left there. You need to put in the area that you're after, and that's the percentage or the probability that you're looking for, and plug in the standard deviation and mean. What I would like you to do every time you do one of these questions is putting down on the side what you used. So your tail was left, your area is 0.07, your standard deviation is 0.02, and your mean is 1.3, because these can help score you some marks if ever something goes wrong. And the value that you'll get for K is 1.27 metres. Part B of this question. It is decided to reject the top 5% of rods. Now what is the maximum length? So the similar process here. Draw yourself a picture. Try and understand what you're working out. The top 5%. So it doesn't actually matter where you put this line. You could draw a great big line there or a little line over here. It's just to give yourself an idea of what you're trying to solve. You can put 5% or put 0.05. It's probably a better one to put. And the value that you're trying to find out is that point there, the end point, essentially the lower bound. So our probability statement is X is greater than or equal to a K value, and the percentage will come out as, the probability 0.05, and the setting out that you need to do is T for tail, A for area, standard deviation and mean. Our tail is to the right, our area is 0.05, standard deviation, what was that? It was on the other page, 0.02, it'll still be in your calculator, and 1.3 for the mean. And our answer that we get for K is 1.33 metres. So that's practicing using a left and a right tail. Second example, second and final one. The life of a xenon battery is known to be normally distributed with a mean of 33.2 weeks and a standard deviation of 2.8 weeks. So straightforward part here, find the probability that a randomly selected battery will last at least 35 weeks. So finding the probability, that's P, that a randomly selected battery, that's X, will last at least 35 weeks. So this is back using NCD, normal cumulative distribution. We've got a lower, upper, standard deviation and mean. Again, feel free to draw yourself a little visual. We want greater than 35. If our mean is 33.2, 35 would be there. So our lower is 35, our upper is, infinity in that sense, and we often write e to the 98, standard deviation of 2.8, and a mean of 33.2. And then plug that in, get yourself an answer of 0.26 or 26%. Now the next part is, this time around, the manufacturer only want 15% of batteries to last between a value, K, and 35 weeks. And we have to find that value. Again, a picture, very handy. What are we actually working out here? I'm going to undo that. I'm going to do a slightly bigger picture. Right. So, put on your mean of 33.2. Put on any information that you know to help you work out exactly how you solve this, because they might not be obvious to start with. So, 15% of batteries is what we're after. Often you'll have to use part A that you've already used for some of these trickier ones. Let's think about what that was. We had 26% or 0.26 in the end for 35. And the key is that we used, there's 35 there and 35 was in part A, so that should trigger your brain to go, maybe I use this 35 again. So that's what we found out from part A. Part B is asking us that some value K, between K, wherever K is, and 35, that probability, so the area under the curve, will end up being 15%. So we can tell that K is therefore going to be on the right-hand side of the mean, so K is going to be here, and that this bit in here, between K and 35, the probability of that will be 0.15. Now, we can't use an NCD on this because we need a lower and an upper bound, and we can't put K into our calculator. But let's see if we can combine this information somehow. That from K to the rest of that function, the probability would be the sum of these two. So how can we draw that? If we've got this part here, it's 0.15 plus 0.26, and what do we get a total of there? 0.41. So the area from K onwards is 0.41. And now you can use inverse normal. So what we're after is actually the probability of K between X and 35, and we want that to be 0.15. So eventually we're solving for K, and the setting out that we need to use for inverse normal here, INV, N, that part doesn't really matter. Tail, area, standard deviation and a mean. Tail, which way do we want it this time? To the right. Area is the size of that area, 0.15. Standard deviation of, what was it? Back on the previous part, 2.8. And a mean of 33.2, and your value for K ends up being 33.84. Just a point that you can do, you could always go back and check this just to see if you've got it right. If you use NCD and you put in a lower and an upper bound of K is what you've just found, 33.84, and an upper bound of 35, you'll end up getting an area of approximately that 0.15, and that's a way of checking that the K value you've got actually gives you the right value that you're after in the question. So that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel. And the next video in this series is finding the mean or the standard deviation. Thank you.